So welcome everybody to this latest GCSE revision video on 162 Maths, and in this video we'll be going over an AQA topic test on the high syllabus with a focus on simultaneous equations. Now as always there will be a copy of the question paper in the description below for you to download and have an attempt at before watching this video and going through the answers. So let's get started on this AQA GCSE Maths higher topic test on simultaneous equations. So looking at question 1, and the key thing to note that this isn't on a calculator. So question 1 says, here is a trapezium, which of these two statements is true? Now there's a couple of facts when it comes to angles inside a trapezium, is that obviously one of the main key principle is that of a trapezium is that we have two parallel lines. So what that basically means is that we've got supplementary angles, so this angle plus this angle, so 2x plus y, I'm missing out the plus 4. Do that, so 2x plus y equals 180, and you can see straight away that that is this first one. I also know that this plus this is also supplementary, so y plus 30 plus x plus 20 also equals 180. So rearranging this, I get x plus y equals 50, take away from 180 is 130, which gives me this statement here. Now another key fact that we probably need to recognise is that all those angles add up to make 360. So 2x plus y plus 30 plus x plus 20 all add up to 360, because angles inside a quadrilateral add up to 360. So if you were struggling in terms of your options, you could have used that other proof. Now the key thing to remember is also with this is that it's not a cyclic quadrilateral, so no opposite angles will add up to 180. So again, we need to make sure that we do recognise that. So moving on to question 2, this is more of our bog standard simultaneous equations. It does say to not use trial improvement, which basically means we've got to show you some working out, but also we're going to need to solve this algebraically. So let's go on to do that. So the first thing you need to do is make either the y's the same or the x's the same. Now it doesn't really matter which one you go for as long as you make one of the letters the same. So for this, just for argument's sake, I'm going to make the x's the same. So I've got 2x plus y equals 13. And if I multiply this equation by 2, I end up with 2x plus 4y equals 34. Then if I take away the two equations, my x's disappear and I'm left with minus 3y equals 13. Take away from 34, which is going to leave me with minus 21. And then from this I get y equals positive 7. Now using one of the equations, so x plus 2y equals 17, and that y equals 7, I get x plus 14 equals 17, so therefore x must equal 3. Moving on to question 3, it says that a tea and 2 buns cost £3 and 2 teas and 3 buns cost £5.10. Work out the cost of 2 teas and a bun. So first of all, let's convert this using algebra. So what I've got is I've got t plus 2b equals £3, and I've got 2t plus 3b equals £5.10. Now if I multiply the top equation by 2, then what I end up with is 2t plus 4b equals £6, and I've got 2t plus 3b equals £5.10. If I take away the two equations because my t's are the same sign and the same quantity, they disappear. I'm left with b equals 0.9. So a bun costs 90p. Now from this, what I can then do is using t plus 2b equals £3. Well, I know that 2 buns is going to cost £1.80. So a tea must cost £1.20. So what I need to do now is work out, well, reading the question, it says work out the cost of 2 teas and a bun. Well, 2 teas is going to equal £2.40, and a bun is going to cost 90p. So that gives me a total of £3.30, which, again, I don't need to have that pound sign because it's already given to me. Question 4 says the cost of one CD and one DVD is £22. A DVD is £4 more expensive than a CD. Work out the cost of a CD and a DVD. So let's first of all use algebra to try and translate each of these statements. So in terms of the first one, we know that C plus D equals 22. And we know that D minus C equals £4 because the difference is 4. So as you can see, if I just rearrange this second one to try and get our c's exactly the same, so I've got minus c plus d equals 4, and all I've done is just rearrange the c minus d. Still, c still negative, the d still positive. Then if I can ignore this, I can then see that my d is the same. So if I subtract the two equations, I end up with 2c equals 18. So 1 CD is going to cost £9. So then using c plus d equals £9, what I then get, so equals 22. C equals 9, so 9 plus d equals 22. So d therefore is going to equal 13. So what I've then got is a CD costs £9 and a DBD costs £13. Then moving on to question 5, again we've got another standard simultaneous equation question, but again here our x's and y's are different. So again, make a decision when you want to make x the same or y's the same. I'm going to go for x's, so we'll multiply this first equation by 3 and the second equation by 2, and let's have a look at what I get. Well, I'm going to end up with 6x plus 9y equals 210, and for the second one I'm going to end up with 6x plus 4y equals 260. Then taking away the two equations, because obviously the x is the same sign, I end up with 5y equals, and it's going to be minus 50, so y equals minus 10. Then using one of the equations, so using 2x plus 3y equals 70. Well, if y equals 3y, that's going to be minus 30 equals 70. I've got 2x, so 2x equals 100, so x equals positive 50. Then moving on to question 6, so this is involving simultaneous equations where we've got one linear, one quadratic. So here what we need to do is just make them, as they're both equal to y, is just make the two equations equal to each other. So I've got x squared plus x minus 3 equals 2x plus 3. Then let's look like quadratic, so you take all of this over to the side, so I end up with x squared minus x equals minus 6 equals 0. And then from this, what I can then do is factorize, particularly as it's on a non-calculated paper, we can factorize, and this becomes x minus 3, x plus 2 rather. So then my two solutions are x equals 3 or x equals minus 2. Now from this, what I can then do is substitute, so using these values, so when x equals 3, and again I'm using y equals 2x plus 3, end up with y equals 6 plus 3, which is 9. So one of the solutions is x equals 3, y equals 9. And when x equals minus 2, y equals 2x plus 3 is going to be y equals minus 4 plus 3, which equals y equals minus 1. So that's my second set of solutions. And so the answers that I should have is, and again I don't really like how they've written this, so let's just get rid of that. So here we've got when x equals 3, y equals 9, and when x equals 2 or minus 2, y equals minus 1. And that concludes this topic test.